My name is Tom Cronin, and in this session on the economics of wind energy, we're going to be looking at some tools for assessing the wind energy economics. So the learning objectives for this session are that we'll be able to calculate the simple payback time of a wind farm. We're going to be able to explain the meaning of the net present value of a wind farm project, and we're going to be able to describe the data and the steps necessary to arrive at what we call the levelized cost of energy for a wind farm project. So why do we need these tools? Well, if we've got the calculation for the cost of building an operating wind farm, and we also know the revenue that we will get from selling the energy production, then how do we actually find out if our potential wind farm is good, if it's going to actually make a profit for us? Well, we have three tools that I'm going to present to you today. The first is the simple payback time, and this really just indicates how many years it's going to take of production before we can pay back our original investment. The second is the net present value, which gives us an idea of whether we should go ahead with a proposed project or not. And the third one is the levelized cost of energy. And this is a way that we can compare our project with other projects. So moving on to the first one, a first basic analysis. This is the simple payback time. And the aim here is to find out how long it's going to take to pay back the investment that we made in the beginning. We have here some figures of a typical wind farm, and we're going to go through a rather simplistic calculation that ignores any time value of money. And this means really that 100 euros next year is worth the same as 100 euros this year, which is not necessarily true in the real world, but for the purpose of this calculation, this is what we assume. So we need to estimate the annual production, and for a 50 megawatt wind farm and the capacity factor, we can get to that. We need the annual revenue, and this is a production multiplied by the electricity sale price. And we also need the annual operating costs, and we know the number of turbines and how much it's going to cost for each turbine, so we can find that. And the simple payback time simply is we take that capital investment at the beginning and we divide into it the annual revenue minus the annual costs. And this will give us how many years it will take of operation before we pay back our original investment. Very quick, very simple, and gives a rough idea for this wind farm project. The second tool then is the net present value. And the aim here is to help us decide if a proposed project is attractive for putting our money into. The definition of net present value is that it is the sum of the cash flows, and this means it's the revenue minus the costs, the sum of the cash flows in today's money. So that means we need to translate money in the future back to today's money. And then we subtract the original investment. This is the net bit. And what we get out is a measure of the attractiveness of this investment. And in general, although there are many other factors, if the NPV is greater than 0, then the project will be profitable and we should continue with it. If it's less than 0, then it's likely that the project is not going to be profitable and we should stop and look at why, or we go on to a different project. Looking at this graphically then, what we have here is we have the income from the electricity sales in each of the years of operation, and we have costs from the maintenance and operation, again for each of the years of operation. And over here, we then have the original project capital investment. So for each of these, we need to discount them according to the year to bring them back to today's money. And then what we do is if we sum each of these up and then take away the original investment, we get the net present value, or NPV. And hopefully for projects, and indeed for this one, we get a positive NPV. Just looking at some of the figures then for this net present value calculation, the same figures really as we used for the simple payback time. Here we need a time. We assume that the wind farm will operate for 20 years, so we have 20 years of production. We know how much it's going to produce. We know what we're going to get per kilowatt hour. We also know how much it's going to cost for us to maintain the wind turbines. And here we've introduced this discount rate. Now the discount rate is the value that we use in order to translate money in the future back to money in today's value. And the simplest way really to do this is we can use a spreadsheet such as Excel, which has an NPV function. And we feed these figures into this NPV function, and in this case the wind farm project has a net present value of around about 6 million euros. So this project we should continue with looking at. The third tool then is the levelized cost of energy. And the aim here is to find a cost per megawatt hour that can be used for comparison. Now the information that we need, the data that we need, is quite similar to the other two tools in that we need the capital investment, we need the operational costs and the decommissioning costs. What we don't need though is the revenue, which would be up here. So please note that this calculation is really only a calculation on costs. We're not looking at the revenue. So it's a means of comparing costs of one project with another, or one type of generation with another type of generation. So what we do is very much like the NPV. We discount all these values here back to today's money. Here we had the costs during the operation of the wind farm. Here we had the initial investment. We discount them all back to today's money. Then we use an accounting technique called amortization. And really all this does is it translates a lump sum in today's money and spreads it out over the lifetime of the wind farm so that we get an equal amount of the costs for each year of the wind farm operation. Then what we need is the annual energy production. And here you can see we also have a figure for each year of production that is the same. We know it's not going to be the same. It's going to vary up and down. But what we need for these economic calculations is an average value. So when we have these two, we can then put one on top of the other, and we have the levelized cost for production and we have the actual production figure. And if we put these two together, then we get the levelized cost of energy. Just working through that again, we need to find all the costs. We need to discount these costs to the present day, just like we did in the net present value. We then need to level them out over the lifetime of the wind farm. We need to find the annual energy production, the AEP. And if we divide the AEP by the annualized levelized cost, then we get to the levelized cost of energy for our project. So in summary, what we've been through now is that we can now make a simple calculation that indicates how long it's going to take for us to pay back our original investment. That was tool number one, and that was the simple payback time tool. The second one that we looked at helped us with a decision as to whether we're going to go ahead with a project. And here we evaluated the net present value of the project using the NPV tool. And finally, to enable us to compare different projects, to compare the costs of generation from different projects, we looked at calculating the levelized cost of energy using the LCOE tool.